So now I have talked about that detector as well. So we only have one thing left now, and a small part on the EDS when we're doing low resolution, low magnification work in EDS. I mean, sometimes that happens also, and many people think that can be easy.
Oh.
All right, so here we have the particles again. So we go up to the EDS place. We can make a
New specimen.
new specimen. You can call it new specimen. And let's grab an image of that. So this is view field is 10 micrometer. This is like the view field here is almost the size of the spot. You remember the information volume we got. So we can do a scan on that just to compare with that STEM data. You remember that it was about 50 nanometer wide, the signal, when we scan across gold. This is as good as we get. I mean, you remember that in the STEM image, do I have it left here? This was the SC signal, the top left image there. So these, I mean, it looks so much better in the STEM. The resolution is so much better.
Yeah.
So, and now this is the backscattering signal. So this is not the SC signal. I mean, there is a difference in resolution at least. Those particles, I mean, this is about 10 times lower magnification compared to the STEM image that I have here. Take up the image here to read this. Let's try to acquire a line across. Cool. Looks like it's so small we don't even pick up a signal on it. It's too much background with silicon and things around.
There's chrome.
We see gold here in the spectra.
Osmium.
But we cannot resolve it. We measure gold, but we cannot resolve it. So this is a nice demonstration of this, how to improve lateral resolution by using the STEM. So let's try to scan something of even bigger. Thought there was some bigger site in the middle there. Let's scan. I mean, we see here the scale bar here, 1 micrometer.
Yeah.
That is like the spot size is like that. In this user case. So I was thinking we can scan all the way across this part.
Okay.
But I don't think that will be enough either, actually.
So it doesn't automatically measure gold?
Yeah. It's so much silicon versus so much compared to how much gold we have. See, you can't pick it up. let's try an even bigger one. Here we have a large aggregate. So a lot of particles there, right? New site, start. So now it's 10 microns, the scale bar there. So the whole object there is about 10 micron wide. And since this is silicon and gold is of course quite dense, so I mean at least a couple of microns we probably have. So let's scan straight across here.
How many spots do you have now?
The spot size is 4 nanometers.
No, I mean the points.
100 points.
Okay.
So 100 points on the line.
Will it be better if you increase
Yeah, you can change that. I mean, the idea is, I mean, it stays at each point and do a measurement for a certain amount of time, and then it moves over to the next point, the next point, the next point. But then it just starts over and scan and scan and scan. So that's why we usually scan until we click stop. So we just wait for the statistics to come up. If we see the statistics here, we can change the scale, I think, here. Can't we do that? I mean, we don't want to reset. I would like to. It says counts per second. I would like to have total count. Perhaps it doesn't show that in line scan. So you have to survive on that. But I mean, you see that on the noise level, there is some higher peaks, at least in the center part here.
Yeah. And
that correlates to this obstacle. But it's very, very weak signal. In the spectra, we see that there is counts, but I mean, here perhaps we can have units counts. So now we have 200 counts there on the goal. So we do detect goal there, but we cannot measure some lateral resolution here. It's but in the stem, it worked perfectly fine. We actually made some trace there.
Yeah.
So that's very nice. So that was a good sort of flashback in comparison to that. So the last part, low magnification in EDS. So let's stop this. What happens when you're running something at very, very low magnification? So let's remove this detector as well. So we remove the backscatter detector and we go to SC now, and we are in analysis mode. So let's say sometimes you want to do a line scan over a large distance like this, several millimeters. It can be like in metallurgical things, a weld or something like that you want to scan. And if you just do that straight on here. Now, this is very nice because we know this is a silicon wafer. It's all is silicon. It's super flat also. So it's ideal from an EDS perspective. Here we can see the dry drop in the corner. So what I want to do now is I want to make a very big line. Here we can see the silicon signal. It's a lot down here. And then when we scan upwards, the signal goes down.
Why?
Let's look on the geometry. So here is the sample, here is the detector. When we're scanning several millimeters back and forth here, the angle the X-rays is entering the detector becomes so far away, so we actually start to lose intensity that goes into the detectors. This is a geometrical error.
I see.
So we know that since it's a silicon chip, it should be like 100% silicon everywhere.
Yeah.
But we see a major gradient here. We can change the scan direction also. Let's try scanning like orthogonal like this. You see, then we get the similar way in the other direction. So it depends on where we are versus the detector. So this is a complete artifact. And if you're doing long scans like this, it's very easy to fool yourself. You think that the concentration goes down with the material you're having or something like that. Mm. So one way to solve this is to change the geometry here. We can actually sacrifice the intensity of the detector by pulling it out. Mm-hmm. So let's pull out the detector a little bit. Then the intensity will go down. Mm-hmm. But from this position, those 3 millimeters will be less space angle seen from the detector, right? Mm-hmm. So if we redo our scan, you see now the signal is more flat. Yeah. So, what shall I say? The geometry of the detector being too close and you having too long scan line is becoming reduced. So we still have, you see, now we at least we have signal over the whole scan, but it still sort of bends down.
Yeah.
So we can try to pull out the detector even further. Take it all the way back. This is the maximum position. Now you see it's almost flat.
Yeah.
So it's improved a lot. All right. I think that sort of wraps up the session.